So we have the real world link on chapter 4, lesson 8, page 325, dividing mixed numbers. The deepest point in the Earth's oceans is the Mariana Trench, which is located 6 4/5 of a mile beneath the ocean's surface. The average depth of Earth's oceans is 2.5 miles. By contrast, the highest elevation on Earth, so the highest point on Earth, is Mount Everest, which is about 5.5 miles high. So that's it's pretty cool to think of that in perspective. So if you are thinking of Mount Everest and you think of a big tall mountain and how giant it is and how it makes you feel so tiny, that's not even as tall as the deepest trench is in the ocean is deep. Okay, so the tallest mountain in the world is still doesn't have the height or depth of the deepest trench in the world. And I'm going to zoom out so we can see this entire page. And so when we think of that, it's pretty impressive because Mount Everest is huge. Okay, so it's 5.5 miles high, but the deepest trench in the ocean is 6 4/5 of a mile deep, okay, beneath the surface of the ocean for comparison. So we write a division expression to find out how many times as deep the Mariana Trench is than the average depth of the ocean. So that's fine. So we're starting off, we want to compare the Mariana Trench. How many times as deep is it? So 6 4/5. Okay, and then divided by the average depth. Oh, so they said the average. Okay, the average depth. So the Mariana Trench compared to the average depth of the ocean is only 2.5 miles. Okay, only 2.5 miles deep. So then we want to write a division problem to express next how many times as tall Mount Everest is than the average depth in the ocean. So Mount Everest is 5.5 miles high, so 5.5. Oops, I wrote the fraction bar in there, but it's already in there for us. Divided by 2.5. So then we want to talk about rewriting mixed numbers as fractions. Okay, so in order to divide by fractions, we need to multiply by the reciprocal. Well, we can only take the reciprocal of a number if it is in a proper, or if it's written as numerator and denominator. So we may need to rewrite mixed numbers as improper fractions. So they only have numerator and denominator. And that's what we're going to practice right here at the bottom of this page. Rewrite the mixed number 6 4/5 as an improper fraction. So 6 4/5 is called a mixed number. It's called mixed because it has a whole number and it has a fractional part. And then if we want to write it as an improper fraction, we want to have only a numerator and denominator. And it's improper because our numerator is going to be bigger than the denominator anytime we have a fraction that's larger than 1, which we do. This one's almost 7. So to change from a mixed number to an improper fraction, there's still fifths. Okay, these are the pieces. That's just what our fractional piece is that we're looking at, the size. So there's still fifths. Let me make my 5 a little bit neater so it doesn't look like a 6. So what we do is we say, okay, we have 6 wholes. Okay, these are the entire pieces. So 6 wholes. And if you took each of those wholes and divided it into fifths, you would have 5 times 6. You would have 30 fifths. Okay. Plus you have these 4 here. That's why you add on those 4. So 5 times 6 is 30, plus 4 is 34. So 6 4/5 is the same as 34 fifths. Okay. And that should make sense to you because if you think of 6 wholes, so I like circles, but they are actually a little trickier to divide up into 6, but let's just pretend I'm doing this perfectly. 1, 2, 3, 4, 5, 6. And then you take each whole, so you have 6 wholes, and then you divide it into fifths, which is kind of like a star. So I'm going to cheat a little bit and just draw a star in there. And then make these my points. Okay, and then I just needed that one little visual to help me. Okay, 1, 2, 3, 4, 5. Okay, so if I do that for all of these, That one's so small. Okay, so I have 1, 2, 3, 4, 5, 6 holes. And then I need to also have this 4/5. So I'll make one more. Okay, but I'm missing this one. So I'm just gonna gray that one out. Okay, so I have 1, 2, 3, 4, 5, 6, and 4/5. So if I think of each of these 6 holes, right, it's 5 pieces in each of those 6 holes. So 5, 10, 15, 20, 25, 30, plus these 4. So 34/5. And that's the reason why we multiply the 5 times the 6, because we have 6 holes, 6 pies or pizzas, whatever you want to think of. And each of those is divided up into fifths. So how many fifths do you have? Okay, 6 holes times 5 fifths in each one would be 30, plus these 4. Okay, gives us 34/5. So that's the reason why we do 5 times 6 and then add 4. All right, so let's do number 4. Rewrite the mixed number 5½ as an improper fraction. So we do the same thing here. We have halves. We have 5 wholes, which is going to be 10 halves. 5 wholes have 10 halves. So 2 times 5 is 10, plus the 1 here, we have 11. So 11 halves. So this page was just kind of for perspective. We have an example. Mount Everest is a fractional size of the deepest trench as far as measuring the sheer height of it. And then we just had a little bit of practice at the bottom of page 325, changing from a mixed number to an improper fraction. All right. So questions on. All right, now we're on page 326 and we're looking at dividing a mixed number by a fraction. Dividing mixed numbers is very similar to dividing fractions. To divide mixed numbers, you write the mixed numbers as improper fractions and then divide the same way that you did with fractions, okay? So let's take a look at example 1 on page 326. We have 1 3/4 divided by 2/5. So here's our 1 3/4. We're just going to rewrite that as an improper fraction. So 4 times 1 is 4, plus 3 is 7. So we have 7/4. We're going to change the divide 2 times, and we'll change the 2/5 to 5/2 because that's the reciprocal. So remember, the first number does not change. This is the amount that we are given. We're given 7/4. Okay, here it was just expressed as 1 3/4, but that's the same as 7/4. We will change our divide to times. And then if we change divide to times, we have to change this 2/5 to 5/2. And the reason we do that is because remember, 2 divided by 2/5 means 2 divided by 5. So if I change the divide to times, I have to change the 2 divided by 5 into a 5 divided by 2. So that way I'm not changing the value of my problem. Then I check first to see if I can do any cross canceling to simplify. We like to check to see if we can simplify because that makes our numbers smaller and a little bit easier to work with. And we're less likely to make a mistake with smaller numbers. And then we check 5 and 4. These two don't have any common factors to factor out either. Okay, so then we have numerator times numerator. 7 times 5 is 35. Denominator times denominator. 4 times 2 is 8. 8 can go into 35. So this is 35 divided by 8. That can go in 4 times. And then how many eighths would we have left over? Okay, well, 4 times 8 is 32. And then you count up to 35, 33, 34, 35. So 3/8 left over. If you have a hard time going from that improper fraction to the mixed number, just remember it's a division problem. Okay, so we can do 35 divided by 8, 35 divided by 8. So this will go in 4 times. 4 times 8 is 32. And then you subtract 35 minus 32 is 3. We used to say remainder 3, but now we say 3 out of 8. So 3/8, 4 and 3/8. Okay, example 2, we have 3 3/4 divided by 4/5. So we will change the 3 3/4 to an improper fraction. 4 times 3 is 12, plus the 3 in our numerator is 15. So 15/4. Okay, we are going to change our divide to times. And if I change the divide to times, I have to change the 4/5 into 5/4. And then I check to see if I can cross cancel. 15 and 4 do not have any common factors. Okay, so I can't cross cancel on this diagonal. 5 and 4 do not have any common factors, so I can't cross cancel on that diagonal either. And then we multiply straight across. 15 times 5 is 75. 4 times 4 is 16. Okay. So then I use my estimating. Remember how we had to do our estimating with fractions? Okay. Finding compatible numbers. So 16 doesn't go evenly into 75, but 15 I can count pretty easily by. So I'm going to count by 15s to get me close. And this is why we needed to do that estimating with fractions earlier. So we had, okay, 15, 30, 45, 60, 75. So 15 would go in 5 times, all right? And that is a really good estimation because that's going to help us to get to our whole number. Okay, so again, I just want to remind you that is why we did those compatible numbers and that estimation. It's going to get us close. So again, we don't really know 16s very well, but we can count by 15s very easily. It's just plus 10 plus 5, okay? So 15, 30, 45, 60, 75. All right, so we can go ahead. 15, 30, 45, 60, 75. So we can have that. It's going to switch out to 4. And then how many 16ths would this be? So 5 would be a little too high because we had 16, not 15. So we're just going to round down. We'll try the 4. 4 times 16. 4 times 6 is 24. Write the 4, carry the 2. 4 times 1 is 4 plus this 2 is 64. And then we count up from 64 to 75. I would need 11 more. So that would be 4 and 11 16. So 5 was our estimate. The actual answer was 4 and 11 16. So that's pretty close. Okay, let's go ahead down here to got it A, B, and C. At the bottom of page 326, I can get my camera to zoom in there. There it is. Okay. So 2 3/8 divided by 1/4. So first we want to change that mixed number into an improper fraction. And so 8 times 2 is 16. Plus this 3 is 19. So 19 eighths. And then we'll change the divide to times. We'll change the 1 over 4 to 4 over 1. We check to see if we can cross cancel. 4 and 8 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So then we multiply numerator times numerator to get 19. Denominator times denominator to get 2. Okay. 19 divided by 2. That's going to be 9. Okay, because 9 times 2 will give me 18. But I need 1 more to take me back up to the 19. So 9 and 1/2. Okay, and you can divide this out as a division problem if you don't like the mental math part of it. You can always divide this out over on the side, 19 halves. You can just work right over here, 19 divided by 2. Okay, so how many times does 2 go into 19? 9. 9 times 2 is 18. 19 minus 18 is 1. We used to say remainder 1, but now we say 1 out of 2. So 1 out of 2, 9 and 1/2. Okay, so you can do that with mental math, or you can divide it out with long division. Your choice. Letter B. We have 2.5 divided by 3/7. So first we need to change this mixed number to an improper fraction. 2 times 2 is 4. 4 plus 1 is 5. So we have 5 halves. We're going to change the divide to times and 3/7 to 7/3. We check to see if we can cross cancel because that will keep our numbers smaller. 7 and 2 do not have any common factors. 5 and 3 do not have any common factors. So we can't do that. So we just multiply numerator times numerator to get 35, denominator times denominator to get 6. And then we know 6 times 6 would be 36, but that's too big. So it can only go in 5 times. Okay. 5 times 6 is 30, plus 5 more will take us up to 35. So 5 and 5/6. And then letter C, we have 5 and 5/8 divided by 3/4. So again, we need to change that mixed number to an improper fraction. 8 times 5 is 40, plus 5 is 45. So 45/8. We're going to change the divide to times. If I change the divide to times, I have to change the 3/4 into 4/3. thirds. Okay, 45 and 3 are both divisible by 3. And let me show you a little fun fact about dividing by 3, or tell you a little fun fact about dividing by 3. You can tell if a number is divisible by 3. Here's a tip, and you may have learned this in elementary school. You can tell if a number is divisible by 3 if you add up the numbers, 5 plus 4. We want to see if it's divisible by 3, right? 45. So you add up the numbers. 45 is 4 plus 5 is 9. Is 9 divisible by 3? Yes, it is. Then you also know that 45 will be divisible by 3. Okay, so you add up the digits. 5 plus 4 is 9. Is that number 9 divisible by 3? Yes. So that tells us that 45 will also be divisible by 3. Okay, so 45 and 3 are both divisible by 3. 3 divided by 3 is 1. And 45 divided by 3 is 15. Okay, and there are other fun divisibility rules too. We'll learn those kind of as we go. All right, then 15, and then 4 and 8. Can we cross cancel there? Yes, we can. We can cross cancel there as well. 8 and 4 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And now we have smaller numbers that we're working with, which we like better. So 15 times 1 is 15. 2 times 1 is 2. So we have 15 halves, which we can rewrite as 7 and 1/2. Okay. All right, and then we're actually going to skip the top part of the second page, 327, because it's just the same thing, except instead of dividing by, here's number 3. Instead of dividing by a fraction like we did on the previous page, it's a mixed number divided by a mixed number. So mixed number divided by mixed number. Okay, so we'll skip examples 3 and 4, but let's go ahead and read the instructions at the top. Page 327. To divide, let's get that on the screen. To divide a mixed number by another mixed number, change both mixed numbers to improper fractions. Remember to simplify before you multiply. So when they say simplify before you multiply, what they're asking you to do is cross cancel. Okay, so this is going to work the same way that it did on the previous page when we had a mixed number divided by a fraction, except both of the numbers that we're working with now are mixed numbers. We have to change both of them to improper fractions, and then we can multiply by the reciprocal. Okay, so let's go ahead down to the bottom of the page. Examples D, E, and F. Okay, and I'm going to bring this a little farther down so it's not on my computer wires. Okay, example D, E, and F. All right, so D, we have 4 and 1/5 divided by 2 and 1/3. So first we need to change these both to improper fractions. 5 times 4 is 20, plus 1 is 21. So we have 21/5. We're going to change the divide to times. Then we have 2 and 1/3. So we need to change this to, let's leave it divide for now. And then we will, we're going to run out of room here actually. So let's work over in the work zone on the left side of the page. So let's actually, changed my mind, just so we don't have to write so tiny. Let's work at the top of this page. Example D is 4 and 1/5 divided by 2 and 1/3. Okay, so 4 and 1/5. 5 times 4 is 20, plus 1 is 21. So this gives us 21/5. And then we're going to leave the problem as a division problem for now while we're changing these to improper fractions. 3 times 2 is 6, plus 1 is 7. So divided by 7/3. Okay, so 21/5 divided by 7/3. So remember, we leave that first number alone. That's what we have. We change the divide to times. And if I change the divide to times, I have to change 7 divided by 3, 7/3, into 3 divided by 7, 3/7. And then I want to check to see if I can cross cancel, because that is going to make my numbers smaller and more convenient to work with. 21 and 7 are both divisible by 7. 21 divided by 7 is 3. 7 divided by 7 is 1. So now I can multiply numerator times numerator to get 9 and denominator times denominator to get 5. I rewrite that as a mixed number. 5 goes into 9 one time with how many fifths left over? 4. So our answer for got it D is 1 4/5. Okay, let's do exercise E. That is 8, which I'm going to write as 8 over 1 divided by 2.5. So 8 divided by, and then I'll change that 2.5 into an improper fraction. 2 times 2 is 4, plus 1 is 5. So 5 halves. All right, and then 8 over 1. I'm going to change my divide to times, and if I change divide to times, I have to change 5 halves into 2/5. Numerator times numerator is 16. Denominator times denominator is 5. 16/5. Okay, how many times does 15 go into, or excuse me, how many times does 5 go into 15? 3 times. Okay, 3 times 5 is 15, plus 1 more to get us to 16. And if you have a hard time going from 16/5 to 3 1/5, that's okay. If you can't do that in your head yet, no big deal. You'll get there eventually. So don't even worry. Just over here on the side, all you're going to write is 16 divided by 5. Over here on the side, 16 divided by 5. And then how many times does 5 go into 16? 3. 3 times 5 is 15, and we subtract. We used to say remainder 1, but now we say 1/5 because we had 1 left out of the 5 that we were dividing by. So 3 1/5. Okay. So again, you can do it with mental math, or you can work out that little division problem over here on the side. Either way is fine. Okay, so here's my mental math thought process. When I go from here to here, I know these are my pieces. So I know I'm going to have some fifths left over. And I say, how many times does 5 go into 16? It goes in 3 times. And then I write my denominator 5. So then I ask myself, what's 5 times 3? 15. And then how many more do I need to get up to 16? How many more fifths? I need 1 more to get up to 16. So 3 1/5. Okay. But you can always do that division problem. Okay. So you don't have to do it with mental math. All right. And let's do one more problem together. Let's do example F. Slide our camera down or page down. So letter F is 1 5/9 divided by 2 1/3. So I'm going to leave it as a division problem for now and change my mixed numbers into improper fractions. 9 times 1 is 9, plus 5 is 14. So I have 14/9 divided by 2 times 3 is 6, plus the one we carried is 7/3. Okay, so now it's a division, it's still a division problem, but I don't have any mixed numbers. Now, and I know that in order to divide by a fraction, I need to multiply by the reciprocal. I just bring down the 14/9. That's the amount of items or whatever that I have. Okay, so that's what I have. That's not changing. I'm just dividing it into pieces. So I'm going to change my divide into times. I change my 7/3 into 3/7. And then remember, before I start multiplying, because I'd rather not have what is that? 42. I don't want to have big numbers. Okay, I'd rather have smaller numbers. So I check and see if I can cross cancel first before I multiply. And I can. I can cross cancel twice, actually. 3 and 9 are both divisible by 3. Okay, so 3 divided by 3 is 1. 9 divided by 3 is 3. 7 and 14 are both divisible by 7. 14 divided by 7 is 2. 7 divided by 7 is 1. Then I can do numerator times numerator to get 2. Denominator times denominator to get 3. So my answer is 2/3. Okay. So again, when we are multiplying by, or excuse me, when we're dividing by mixed numbers, first we have to change those to improper fractions. And then once they're improper fractions, we instead of dividing by the fraction, we multiply by the reciprocal. Okay, so very similar to dividing fractions, but remember we have to change those into improper fractions first. So we have